Hello, grade 12s. If you're with me right now, that means you have finished your major project and that's been handed in via email, mriati at ldcsb.ca. And then you've also finished your combinations test, and that's handed in on under assignments in D2L. So we have two more units left, and this is a little bit of a longer one. Probability, there's going to be a few lessons with it. And then the last one is going to be a quick, short one. So we're going to try to get that all done before the report carding period starts so that I can get those marks in and they'll be updated on your report card. So let's get started here. We're going to start with probability. And so here's the lesson. Okay, so there's going to be 3 lessons on probability. There's 3 days of lessons on probability. Here's day 1. Experimental probability is the first. So what is probability? We see it in our everyday lives on the regular. How likely is it to snow? Any kind of percentage chance, that's all probability that they're giving you. Sports, gambling, etc. Any kind of odds that are being given, that's also probability. And we apply it to our everyday life. We often will talk about, what's the odds of something happening. So that branch of mathematics attempts to predict basically things that are going to happen in the future. It's related to chance. So typically your probability is, it's not regularly 1.0 or 100% chance. It's somewhere less than that. And using mathematical techniques, we can calculate how likely it is for an event to occur. And we'll show you some of those techniques. Remember, if it's less than 1.0 or 100% chance, there's always that potential, however slight, that the opposite thing could occur. So probability measures the likelihood of an event occurring, as I said, anywhere from 0, the impossible, to 1.0, the certain. So 1.0 or 100% chance, that's going to happen for sure. A review of what we saw before. There's outcomes, possible things that can happen. So possible outcomes of rolling a 6-sided die are 1, 2, 3, 4, 5, or 6. So that's within our sample space, there are a certain number of outcomes. The event that you're looking for is a subset of all the possible outcomes. So say you're looking to roll a 6. That is the event you want, which is 1 out of 6 possible events. So rolling a 3 on a die would be an example of another event. Sample space of an experiment is all possible outcomes. And we've seen that when we were doing Venn diagrams. So we should be somewhat familiar. So in probability, it's the event you want divided by all possible events. It's the easiest way to remember it. Here we're listing the possible outcomes. So all the possibilities, the sample space. List the sample space. So we've got 1, 2, 3, 4, 5 different colors. The sample space is the 5 colors. Rolling a die. Assuming it's a 6-sided die, you got 6 outcomes possible. Playing a game of tic-tac-toe, you can win, you can lose, or you could tie. Tossing 2 coins, you've got heads, tails, and the second coin you got heads or tails. So it could be heads, heads, it could be heads, tails. If the order matters, it could be tails, heads, or tails, tails. Choosing a date in February. You've got 28 days in February. So there's your sample space. Probability of an event, P of A. is how many ways the event can happen divided by all possible events. We're looking at two different varieties, the empirical and the theoretical. The theoretical is what you would typically think about in this course. So theoretical probability, you're trying to use counting techniques, either permutations, combinations, or something else, to predict what's going to happen. That's theoretical. The empirical is experimental probability. That's actually doing an experiment, actually rolling the die and seeing what happens. That gives you the experimental probability. Again, number of times an event occurs divided by all trials this time because it's experimental. So in theoretical, it's the event you want divided by all possible events. In experimental, it's the event you want divided by all possible trials. How many times did you try to roll a 6? That's your denominator. And how many times you actually rolled it? That's your numerator. If you rolled a die 10 times and a 4 came up 3 times, then the empirical probability of this event would be 3 out of 10. So the 4 came up 3 times, so that's the 3, divided by how many times you rolled total, which was 10. Theoretical, that's what the majority of this unit is going to be about, and that's called classic probability. Using counting techniques, you solve kind of the issue. Probability of rolling a 5 on a 6-sided die. How many 5s are there? There's 1 out of how many possible? There's 6. There's your theoretical, which is, again, what the majority of this unit is going to be about. All right. You don't need to do this, but conduct each of the following experiments to determine the empirical probability of each event. Flip a coin 4 times and record the number of heads. Combine the results with the whole class to determine the experimental probability of obtaining 4 heads, or 0 to 4 heads, in 4 flips of a coin. So we need the number of heads. So I'm going to show you how to do that using Excel. Okay, so we need heads. So the easiest way to do this is equals rand, which is another way of saying random, short form, rand between. Random between, and you've got one is your bottom, 2 is your top. 1 is heads, 2 is tails. So I'm just going to write that over here. 1 is heads, so therefore 2 is tails. Okay, so rand between 1 and 2, and you needed to roll the die 4 times, or sorry, not flip the coin 4 times. 1, 2, 3, 4. So there you go. We've got 2 heads and 2 tails. And then we wanted to do that, let's say, for 30 people. So there's my 30 people. Now, I could go in and try to count. So I could go 2 and 2 is there, 2 and 2 is there, 3 and 1, okay, fine. I could do that. Or I could use count if. All right, I just want to know how many heads I have. So I got 2 heads. So my E column is how many heads. And there's my totals. So I got 1 head, or 2 heads, or 3 heads, counting all the way down, and you got 30 different people, and then you could tally that up and make it into a chart. You could also go 1 head, or 2 heads, or 3 heads, or 4 heads. equals count if, and I'm just going to look at that last column. Count if it is a 1. I should probably put 0 in there as well. I could get 0 heads. So let's go 0 equals count if highlight again. If it's a 0, that means there was all tails. So 2 all tails, 1 all heads. Let's copy this. I'm going to paste it. Copy, paste, paste.